All right, thank you so much for joining us today. In this video, we are going to consider case 2, and then we are going to talk about polynomial functions. So here we are looking at the idea that the non-homogeneous aspect is a polynomial function. So we saw that we have trial solutions that we need to guess, but don't worry memorizing this. All you need to know is with the polynomial function, remember the first term here, right? So let's take example to practice and show you how you can choose your trial solution whenever the non-homogeneous aspect is polynomial. Right. So let's start the same idea again. So we saw from the previous video that here we need to start with the general solution. And we know that general solution is basically the complementary solution plus the particular solution, right? And then we are saying that for, for complementary solution, we need to pick the right side of or the left side of the non-homogeneous equation and we set it to what? 0. Then we take the process. So now let's go through the process by determining the characteristics root. Good. So we start by saying that y is equal to e to the power mx. Y prime is going to give us this. So you see that we are going through the same process again, and basically this helps you to master the procedure. This helps you to always be checking how things are going, right? Good. So let's go through fast. So this is going to give us m squared e to the power x. So I think I didn't say this. We are going through 4 questions, and then at the end of the 4 questions, I'll give you a trial question to do and drop your answer in the comment section. So stay here with me. Let's go. So plus 3 y prime is going to give us e to the power mx minus 4 e to the power mx is equal to 0. Same idea. Let's factor e to the power mx out. We are going to have with m squared 3m minus 4 is equal to 0. Set this not to be 0, and then we are going to assume that the characteristic polynomial is m squared plus 3m minus 4. So now let's try and solve this. So I'm going to assume that this plus this minus 4 is equal to 0. So I see that this is not going to give us complex because when I square this and when I multiply this one by that, it's going to give us complex. Yeah, this is going to give us complex. So basically, let's use the quadratic. So let's go to the quadratic. This is going to give us a is 1, b is 3, and c is -4. So this is going to give us something like complex, I think so. So let's try and then use the quadratic formula. So quadratic formula is minus b plus or minus square root of b squared minus 4ac divided by 2a. So now this is going to give us m, which is equal to b is 3 plus or minus square root of 3 squared minus 4 times a times c. Oh, this is not going to give us complex. I didn't see that. But it's okay. So this is going to give us minus 3 plus or minus. This is going to be 9. Now, because this is minus, this will be positive. So this is going to give us plus 16 divided by 2. And this is going to give us minus 3 plus or minus square root of 25 divided by 2. This is going to give us minus 3 plus or minus 5 divided by 2. So here we can pick m1 to be minus 3 plus 5 divided by 2, which is going to give us 2 divided by 2, and it's 1. And we can pick m2, which is equal to minus 3 minus 5 divided by 2 minus 8 divided by 2, which is equal to minus 4. So we have m1 and m2 to be distinct root, right? Distinct root, and they are real. So we can consider the complementary solution. So the complementary solution is going to be yc, which is equal to c m1x plus c2 m2x. So complementary solution is going to be C, M1 is 1, then M2 is minus 4. So 2e to the power minus 4x. So this is the complementary solution. Let's go and figure out the particular solution. Oops, I didn't leave a space for solving this. Okay, so let me add one page to this. Okay, so don't mind this, it's the same thing again that we are solving. So now that we are done with the complementary solution, we have the equation here. So what we just need to do is we need to write the complementary solution, which is y is equal to c1 e to the power x plus c2 e to the power minus 4x. I hope that's right. Good. So now that we have the complementary solution with addition to the original equation here, we know that general solution is yc plus yp. So now let's go for yp. For yp, we guess y to be equal to. So now remember, this is not exponential function. This is a polynomial function. So we need to guess a polynomial function, which is what? Linear, because the degree here is 1. So we are going to start by saying a0 plus a1x. But when you get to the x, that's where we are going to stop because this is having a degree of 1. So we need to stop at 1. If this one is squared, then we need to add a2x squared. We have example with x, so we will talk about it. So now this is what we are going to guess here. This is what you are going to guess from here. Now, what we need to compare here is we need to compare our guess here and see if it is the same as any of the solution here. That's very important. So do you have anything like a constant standing alone? No. Do you have like a constant times x here? No. So it means that this is never the same as any of this here. So it means that this will be our trial solution. This linear function here is our trial solution. You will take another example, which is going to be like we having something like that, and we'll see how we are going to modify the equation too as well. So now that this is not in here, then we need to differentiate this and plug it inside this. So same process, but how to generate your trial solution is what is important. So yp prime is going to be a1, because when I differentiate this, I'll get 0, and when I differentiate x, I'll get 1, so I'll get something like this. And yp prime prime is going to give us 0, because when I differentiate this, it's going to be 0. So now I'm going to substitute this inside this. So I'm going to have something like 0 plus 3 times y prime is a1 minus 4 times y is a0 plus a1x, which is equal to 2x minus 1. So let's simplify. This is 3a1 minus 4a0 plus a1x is equal to, no, this one should be 4 minus 4a1x is equal to this. So let's group like terms. Now we can see that this and this are the same. So when no, they are not the same. Good. They are not the same. They are not the same. Because this is a1, this is a0, and this is a1 by going with x. So let's compare. We compare the term with x here and the term with x here. So the term with x here and the term with x here is this. So when I compare this, which is in terms of x, and this is in terms of x, I'm going to have minus 4a1, which is equal to 2. So what I'm doing here is I want to compare the coefficient of x here is 2, and the coefficient of x here is minus 4a1, which is this. And this will help me to find, this implies that a1 is equal to minus 1 over 2. Is that right? Divide 2 by minus 4 and you get that. And then this is a constant. There is no x. So we need to look for the terms on the left too, which has no x. So minus 1 is here, and this one has no x. So this is equal to this. So we are going to have 3a1 minus 4a0, which is equal to minus 1. Fortunate for us, we know a1 from here, which is minus half, so we can plug it in. So you're going to have 3 minus 1 over 2 minus 4 a1 naught is equal to minus 1. So let's try and solve for that. So minus 3 over 2 minus 4 a naught is equal to minus 1. So minus 4 a naught is equal to minus 1 plus 3 over 2 minus this is equal to. Now this is the same as 1. So we are going to have something like minus 2 plus 3 divided by 2 minus 4 a naught is going to give us 1 divided by 2. Then when I divide this one by 4, I'm going to have a naught to be minus 1 over 8. So we've gotten a naught to be minus 1 over 8 and a1 to be half, minus half. So now let's pick it from the particular solution here. Our particular solution, which is yp, which is equal to a naught plus a1x, is going to be a naught is minus 1 over 8, a1 is minus half, so minus half x. Good. So I'm going to add this one to this, and this is going to form the general solution. So now I can write general solution, which is y, and my general solution. So what is the y complement? We have c1 e to the power x plus c2 e to the power minus 4x plus this, which is minus 1 over 8 minus 1 over 2x. So this is going to be the general solution. So if you can see this, you can see that everything that we are doing, basically we are going through the same process again and again. For example, anytime we want to find a complementary solution, we are going through the same process. And then whenever we are going to the particular solution, the trial solution is what is important. So let's take another example which talks about, the same trial example for polynomial function, but different way of getting it. So let's go through fast. Again, general solution is y, which is equal to y complement, yp. And then we start. So for YC, so you see that anytime you engage with the material like this, you are solving a lot of example, you'll get used to a lot of questions and then how to approach them. So basically that's what I'm doing. I'm solving them for us to engage with the material so that we can solve different type of questions. So that's the reason why I give you different questions with different trial solutions. So let's start again with this. So we know how to do this. Good. So I was just differentiating this, and then here, if this is your first time here, and then y prime prime is m squared e to the power mx minus 5 mx plus 4. So if this is your first time here, what we are doing is I differentiated this, I had this, and I'm just putting this one inside this. So that's basically what you are doing. So from here, this is here, this is here, this is here. I'll factor it out. E to the power m out. M squared minus 5m plus 4 is equal to 0. Then we are going to set this guy not to 0. And then we set this one to be the characteristics polynomial m squared minus 5m plus 4. Good. So now let's find the root. M squared minus 5m plus 4 is equal to 0. Let me use something like, can I just factor two numbers that when I multiply? Okay, I can just do simple factorization here. So m squared minus, you can use calculator to do that. So this one, I need to use something like minus m minus 4m plus 4 is equal to 0. Because minus 1 plus minus 4 is this, and when I multiply 1 to minus 4, I get 4. Good. So now I can make use of this with the blue and this with the green. So with the blue, when I factor m out, I'll be left with this. And then with the green, when I factor minus 4 out, it will be left with m minus 1 again. So I'm going to have something like this, m minus 1, then m minus 4 is equal to 0. So m minus 1 is equal to 0, m is equal to 1, and m minus 4 is equal to 0, m is equal to 4. Good. So I can say that this is m1 and this is m2, or you can interchange it, the same thing. So this is real and distinct. So what will be the complementary solution? The complementary solution is going to be c1 e to the power m1 x plus c2 e to the power m2 x. So this is going to give us something like this: c1 e to the power x plus c2 e to the power 4x. So that's what you're going to get. Now let's go again with the trial solution for the particular solution, but this one is x squared, right? So let me open another page and do that. So we've gotten the complementary solution to be c1 e to the power x plus c2 e to the power 4x. I hope that's right. Good. Let's look for the general solution. Now for getting the general solution, we need yp. So now this is a polynomial function. So let's guess yp should be, now this is square. So it means that we need to guess a quadratic function. So I'm going to have a0 plus a1x plus a2x squared, because this is a quadratic function. So the degree is 2. So I need to end at degree of 2. So this is what I'm going to get for a complementary solution. Sorry, I said the particular trial solution. But when I finish, I need to compare this to this and see if none of them is equal to what is here. This is very important to notice, because you can write this and maybe one of them is repeating itself. If you don't modify it, then your solution will not be right. So this is what I'm going to do. This is not here. None of them too is here, and this one too, because all of them are having ex and we don't have any ex here. So now what we can do is now we can differentiate. So yp prime is going to be a1 plus 2a2x. So I differentiate this 0. When I differentiate x, I get 1, so a1. When I differentiate x squared, I get 2x and then a2, which is here. Prime prime, this will be 0. When I differentiate x, I get 1, so this will be 2a2. So what am I going to do? Plug this one inside this function here. So I'm going to have 2a2 minus 5 times y prime, which is a1 plus 2a2x, and then plus 4y. So plus 4y. Y is a0 plus a1x plus a2x squared, and this is equal to x squared. This is equal to x squared here. Good. Now expand and compare. 2 minus 5a1 minus 10 a2x plus 4a0 plus 4a1x plus 4a2x2 is equal to x squared. So just multiply through by minus 5, multiply through by 4. Now let's see if we can group some terms here. Let's look at the terms with x. This term here is x. This one too is with x, right? The one with the green are no terms with x, right? So let me write the one with the green. So the one with the green is 2a2 minus 5a1 plus 4a0. They are the ones without x. And then the one with x is the one with the red one. So I will factor x out. So I'm going to have something like plus minus 10a2 plus 4a1x. So the one with the red minus 10a2 is here, and then 4a1 is also here. with the x here outside. And then the last term is the one with the x squared, so which is plus 4a2 is equal to x squared. So we are going to compare terms. So we see that we have a term with x squared. So we need to compare with the term x squared here. So the coefficient of x squared here is 1, and the coefficient of x squared here is 4a2. So I'm going to have 4a2 to be equal to 1. And this implies that a2 is equal to 1 divided by 4. Good. Now you ask yourself, do you have a term like x here? No, meaning that it's 0. So this one can be written as plus 0x plus 0. So the term with the x here, which is also x here, the coefficient of this is 0. So anytime I don't have anything here, I pick the term with the x to be 0. So this one, when you compare, it means that minus 10a2 plus 4a1 is equal to 0 because we don't have any term here, which is like 0x. Then I think this one will help us to find, because we know a2. So this is minus 10 times a2 plus 4a1, which is equal to 0. And this is minus 5 divided by 2 plus 4a1, which is equal to 0. 4a1 is equal to 5 over 2. And then when I find a1 will be 5 divided by 8. Then the last one is, we have a constant term here, and the constant term here is 0. We don't have anything, so this one is 0. So this is equal to 0 here. So I'm going to have 2a2 minus 5a1 plus 4a0, which is equal to 0. I know a2, I know a1, so it will help me to find a0. So a2 is 1 over 4, a1 is 5 over 8. 5 over 8 plus 4a0 is equal to 0. So this is 1 over 2 minus 25 divided by 8 plus 4a0, which is equal to 0. Then guess what we can get from here? I'll multiply this to this. So I'm going to have like 8 minus, multiply this one to this, 25, 50. And then this to this will be 16. So this is kind of going to give us something like minus 42 divided by 16. 2 goes here, 21, I think, and 2 goes here, 8. So this is going to give us minus 21 over 8. Please, those who are using calculator, you can confirm that for me. Then plus 4a0 is equal to 0. So now this implies that 4a0 is equal to 21 divided by 8. And divide this one by 4, and this implies that a0 is equal to 21 divided by, I think, 32. 8 times 4 is 32, yes. So a0 is 21 over 32, a1 is 5 on 8, and a2 is 1 on 4. Please check the calculation here for me. If I made a mistake, you can put it in the comment for me to notice that. Okay, so now let's write our solution, which is the particular solution. So what is a0? We had a0 to be 21 over 31, 32 rather, yeah. And then a1 is 5 on 8, so plus 5 on 8x plus a2 is 1 on 4x squared. Is that right? Good. So this will be the particular solution. So I'll just add this one to this, and then I get my general solution. So let me just do that here. So my general solution is going to be y, which is equal to c1 e to the power x plus c2 plus 21 over 32 plus 5 on 8x plus 1 over 4x squared. So this is my general solution. This is my general solution. So it's kind of very simple whenever you are doing it. So now we want to look at this example here. So same thing again, general solution, general solution. We are going to have y is equal to yc plus yp. So for yc, we need to consider y prime prime plus 4y prime to be equal to 0. So let's go through the same process. E to the power mx, y prime is equal to mx, and y prime prime is going to be m squared mx. So we are going to also take another one that's going to give us different general solution, or let me say a particular solution. So this is going to give us m squared e mx plus 4. Y prime is m dot is equal to 0. Factor e to the power mx out, and it will be left with m squared plus 4m, which is equal to 0. And what are we going to get? This, we set this one to be 0, and then p of m is equal to m squared plus 4m. Then for us to get the roots, m squared plus 4m is equal to 0. So I can factor m out, and it will be left with m plus 4 is equal to 0. So here m is equal to 0 and m plus 4 is equal to 0. So we can see that m should be equal to minus 4. So let's assume that m1 is 0 and m2 is minus 4. So this is what we are going to get. So now let's write out the complementary solution. So this is real and distinct. So I'm going to have c1 e to the power m1x plus c2 e to the power m2x. Right. So this is what I'm going to get from here. I'm going to have something like this. Yc is equal to, now with this, I'm going to have c1 e to the power 0 because m1 is 0, and then plus c2 e to the power minus 4x. So my complementary solution will be equal to my complementary solution will go to c1 plus c2 e to the power minus this. Nice, nice. So now that you've gotten complementary solution, now let me show you how you are going to get the particular solution. So now we saw that the complementary solution is equal to c1 plus c1 e to the power minus 4x. And we know that general solution is complementary plus particular solution. So now let's try and figure out the particular solution. So as I said, we need to first guess particular solution. This is x squared. So we are going to have a naught plus a1x, right, plus a2x squared. Now, as I said, when we finish, compare this to this. Now we can see that with this one, we can see that we have a constant here without the ex. So this is a constant, and this is also a constant. We cannot have a constant here and a constant here. So it means that we need to modify this. We need to move to the next solution by multiplying through by x, because this is a constant and this is a constant. So when you see the previous one that we did, all of them were in terms of ex. So we didn't have any term here to be the same as this. So we use this and then we use to solve. But with this one, we have a constant here and a constant here. So we need to modify this solution from this, or let me say, modify this solution by multiplying through by x. So I'll multiply this one by x. So this is what I'm going to get from the general solution because I have a constant here. So when I multiply through, this is what I'm going to get. A naught x plus a1 x squared plus a2x to the power 3. Then I compare again. Now this is a constant. I don't have a constant here, right? Now look at this. Because the second term is in terms of this, then it means that this is the solution that we are going to use, the trial solution that we are going to use. So as soon as you've gotten the trial solution, we need to just differentiate. So differentiate this, you get x naught. Differentiate this, you get 2a1x and then 3a2x squared. So just differentiate this, differentiate that. Then y prime prime is going to give us, this will be 0. This is going to give us 2a1 plus 6a2x. So I differentiate this, x will just be 1. Differentiate this, multiply, get 6, and then you have the x here. So now we are going to substitute this one inside this equation, and then we find a particular solution. So it's very simple from there. So we have y prime prime plus 4y prime is equal to x squared. So let's plug them in. So we have 2a1 plus 6a2x plus 4 times y prime, what is x naught plus 2a1x plus 3a2x, which is equal to x squared. So 2a1 plus a2x plus multiply through by 4, 8a1x plus 12 a2x squared is equal to x squared. So same thing, group like terms. So the terms with x is the one with the red, and the terms with constant without x is the one with the blue. So I'm going to have the terms with the constant is going to be 2a1 plus 4a0. I cannot add them because this is a1 and this is a0. Then the terms with x, 2, I cannot add them because this is a1 and this is a2, but I can factor x out. So I'm going to have plus 6a2 plus 8a1x, and the term with x naught, x squared is just 1, which is 12a2x squared, which is equal to x squared. So same thing like the one that we did from the other question, we compare coefficients. So the one with x squared, x squared. So compare the coefficient, this is 1, and the coefficient of x squared here is 12a2, which is equal to 1. So a2 will be 1 divided by 12. Then this one, there is no x term here, so it means that it's 0. So when you take the coefficient of x, you equate it to 0. So this is going to give us 6a2 plus this is equal to 0. a2 is 1 over 12, so 6 times 1 over 12 plus 8. Multiply this, and this is going to give us 1 over 2 plus 8. This is equal to 0. And I think this one will help us to find a1. So this implies that 8a1 is equal to minus 1 over 2. And when I divide 2 by 8, I get a1 to be minus 1 divided by 16. Good. The last one that we need to do is constant term. There is no constant term, so the constant term here is like 0. So I'm going to have something like 2a1 plus 4a not to be equal to 0. I know a1, so I can find a naught. So 2 times minus 1 over 16 plus 4a naught is equal to 0. So this is going to be minus 1 over 8, I think so, yes, plus 4a naught is equal to 0. So 4a naught will be equal to 1 over 8, and this implies that a naught is going to be 8 times 4 should be 32. So 1 divided by 32. So we've gotten a naught, we've gotten a1, we've gotten a2. So let me go and write my complementary solution again. I say complementary solution, my particular solution again. So this is the particular solution. So when I do that, now this implies that yp is equal to a naught is 1 over 32. So 1 over 32. Okay, let me put it inside this one rather. It's the same thing, but I just want to have the constant term standing alone. So yp will be equal to x. A naught is 1 over 32. A naught is 1 over 32. A1 is 1 over 16. 1 over 16x. And then A2 is 1 over 12 plus 1 over 12 x squared. So this is my particular solution. Add particular solution to this, and then we get our general solution. Nice. So our general solution with the green, y is equal to c1 plus c1 e to the power minus 4x plus x 1 over 32 minus 1 over 16x plus 1 over 12x squared. So this is going to give us our general solution. Very nice from there. So this is the general solution. Let's take one example, the last example, which brings another way of getting your trial solution, right? So this is very simple to go. Like some seconds we will be done. So general solution is equal to complementary solution plus particular solution. And then for complementary solution, we are going to assume that the left side is equal to 0. So let y to be equal to mx, y prime is equal to this, and y prime prime is equal to m squared that. So this is going to give us m squared e to the power this is equal to 0 because we have y prime prime to be 0. Then here we are going to assume that, so this one we are going to assume that e to the power this is not 0. So it means that m squared should be 0 so that the left side will be equal to 0. So I skip one step. My characteristic polynomial should be equal to m squared and it should be equal to 0. So here, when I take the square root of m squared and square root of this, I'm going to have m to be equal to plus or minus 0. And plus or minus 0 is always 0. So this is m1 equal to 0 and m2 is also equal to 0. And we can give them a name m which is equal to 0. So this is a double root where all of them is what? 0, right? All of them is 0. So we know how to find when we have double root, right? So double root, we are saying that our complementary solution should be c1 e to the power mx plus c2x e to the power mx when they are all having the same root. So it means that writing this is going to give us this, and this is going to give us c1 e to the power 0 plus c2x e to the power 0. And this is going to give us c1 plus c2x. Nice. Nice. So now that you've gotten this complementary solution, let's try and figure out our particular solution, right? So they've given us something like this. The original question is y prime prime is equal to x squared, I think. Yes. So now let's find the particular solution. So for particular solution, first we guess a0 plus a1x plus a2x squared because this is squared, a quadratic one. Now compare and see if none of the term here is in the complementary solution. We can see a constant here, a constant here. So no way, we need to modify this by multiplying through by what? X. So let's do that by multiplying through by x. So let me multiply this one by x. Good. So I've done the modification. Let me just multiply again. So this one will be a0 x plus a1x squared plus a2x cubed. Good. Now, when you are done with the modification, what you need to do is compare again and see if you are okay to go. Now, this term here is a0 x, which is not the same as this. So now we don't have any constant again because all the terms here is having x. This does not have x. So let's look at the next term. The next term here is having an x, so a constant and x. Another one again, we have a constant and an x. So this is basically we are saying that it's the same because a0 can be 2, this one too can be 2, and you are going to have 2x here, which is not the case. So it means that we need to modify it again. So how are we going to do this? what we are going to do is we are going to modify this again by multiply this one by x again. And then guess what is going to happen? We are going to have something like this. Yp, which is going to be a naught x squared plus a1 s cubed plus a2 x to the power 4. Now, when you are done, compare again. Now, the x term here is starting from x squared. We don't have any term here which is x squared. So it means that now there's no term here which is the same as this term. So our trial solution now going to be this. So you see how the trial solution started? We started with this. We started from here. We saw that this guy was here. We multiplied through by x. And then we had what is inside the bracket here. So let me just clean this x2. We multiplied through by x and we had this. And we saw that this term here is also the same as this. And we multiplied through by x again and we had this. And we saw that, okay, indeed, now this, we don't have any term which is equal to this. So it means that the trial solution should be the last one here, which is starting from x squared. Good. So now that we're able to figure the trial solution, we are done. And this is the last example, which talks about all the different way of getting the trial solution. So multiply this or differentiate this and get 2x naught x plus 3x1 x squared plus 4a2 x to the power 3. Differentiate again, and we are going to have 2a naught plus 6a1 x plus 12a2 x squared. Good. So we are going to plug in this into the original function. The original function is just y prime prime is equal to x squared. So since it's just y prime prime is equal to x squared, it's very simple. So from here, we are going to have 2a naught plus 6a1 x plus 12a2 squared is equal to x squared, because that is all. So compare. The term with x squared is this. The coefficient of this is 1. The coefficient of this is that. So this is going to be 12a2 is equal to 1. And this is going to give us something like this. This is going to give us something like a2, which is equal to 1 divided by 12. Now the term with the x here, there is no x here, so it's 0 here. So plus 0x. So the coefficient of x here is 0, and the coefficient of x here is going to be 6a1. So this is going to give us a1 to 0. We don't have any term here, so the constant here is 0. So the constant here is equal to 0, and we are going to have 2a naught to be equal to 0, and a naught will be 0. So a naught is 0, a1 is 0, a2 is 1 over 12. So let's try and put it inside. So from here, this was our particular solution. So from the particular solution here, we are going to have yp, which is equal to, now remember, a naught is 0, so this one will disappear. A1 is 0, this one too will disappear. So it will be left with this term, which is 1 over 2, 1 over 12, x to the power 4. So now this is the particular solution. We add it to the complementary solution here, and we get the general solution. So it means that our general solution is going to be y, which is equal to c1 plus c2x plus 1 over 12 x squared. So this is our general solution. This is our general solution that we are going to get from here. This is our general solution. So it's kind of very simple. We've seen the way of, all the ways of solving a polynomial function when you need to multiply through by x, when you need to multiply through by x again, and when you need to maintain the first one that you need to do, and when to guess the trial solution for the first time, looking at the non-homogeneous aspect, whether it is a quadratic, whether it's a cubic, whether it's a linear, or whether it's a constant. Then you take it from there. I think one thing that I need to also put your attention to that I didn't do was, let's assume that we have something like this plus 4y is equal to, let's say, 2. Now you see that this is just a constant, right? And how can you solve this? So anytime you have something like this, what you are going to do is your guess solution for this is going to be just a linear function, because this is a constant. So we need to guess a constant value. Is that right? Or, so is this one, you can use the polynomial function, or you can use exponential. Exponential, you can assume that this is to the power 0, and they used to solve it. So whenever you have a constant, you can assume that this is going with the exponential, or this is just a polynomial function. Any of them works out. So that is basically something that I needed to give example upon it, but I think it was okay. So try this question here and leave your final results in the comment section. So in the next video, we are going to talk about case 3, where we are going to combine a polynomial function and exponential function and see how we can also get the trial solution from that. So see you in the next video.